Right. Let's start talking about the transpose of a matrix. Now, the transpose of a matrix A is found by interchanging the rows and columns of A and is denoted by A superscript capital T or A prime. So again, the transpose of a matrix A is found by interchanging the rows and columns of matrix A, and this is denoted by A superscript capital T or A prime. Example 18 says find A transpose when A is the matrix 3, 9, 2, 8. So this is simply A transpose is equal to, and we are going to have interchange the rows and columns. So the row 3, 9 is going to become the column 3, 9. The row 2, 8 is going to become the column 2, 8. So this would be, if A is 3, 9, 2, 8, A transpose would be 3, 2, 9, 8. All right, example 19. Example 19 says write down A transpose. So for example 19, A transpose, we're going to interchange the rows and columns. So the row 2, 4, the top row 2, 4, 9 is going to become the left column 2, 4, 9. Sorry, 2, 4, 5. Then 3, 2, 6, and 7, 5, 1. So you get A transpose by interchanging the rows and the columns of A. Now, properties of the transpose of a matrix. So property I, the transpose of A transpose is equal to A. The transpose of A transpose is equal to A. That's largely intuitive. I think we could easily see that that is true. We change the rows into columns, and then we change back the columns back to rows. So that's largely intuitive. So the transpose of the product of K and matrix A, where K is a real number, is equal to K multiplied by A transpose. The third property of the transpose of a matrix is that the transpose of matrix product AB is equal to the product of the transpose of matrix B multiplied by the transpose of matrix A. Fine, that's not so intuitive. However, if it is something that's easy for us to determine if it is true or not. Symmetric and skew symmetric matrices, a square matrix A is called symmetric if and only if A transpose is equal to A. Matrix 1, 2, 2, 1 is symmetric since the transpose is also 1, 2, 2, 1. Now a square matrix A is called skew symmetric if and only if A transpose is equal to minus A. Now above all of this in blue, I have 3 by 3 matrix, and I'm going to find the transpose for each of them. So the matrix on the left, that's A, the matrix on the right will be A transpose. So let's do that. So the row 1, 2, minus 4, this is 1, 2, minus 4, 2, 3, 0 is going to become the column 2, 3, 0. Minus 4, 0, 5 is minus 4, 0, 5. So we transpose the matrix on the left, and what we realize is that we got back the same matrix. So here, A transpose is actually still equal to A. So the example here at A, we said that the matrix A would be a symmetric matrix because the transpose of the matrix A is equal to the matrix A. B, here at B, let's transpose. We're going to get 0, 3, 4, minus 3, 0, 7, and this is minus 4, minus 7, 0. And if you look carefully, you'll observe that this is minus A. So all the letters basically end up back in the same position, but their signs change. All right. And the only way that happens is if you multiply the matrix by minus 1. So if you multiply minus 1 by A, you get minus A. So the transpose of A here is equal to minus A. So at B, the B part of the example, the matrix A is skew symmetrics because the transpose of A is equal to minus A. All right, next we're going to look at determinant of a square matrix. Then we're going to start up by looking at the determinant of a 2 by 2 matrix, and this says let A be the matrix A, B, C, D. The determinant of A denoted by A with the 2 strokes at the side, or DET, A in bracket, is given by the determinant of A is equal to AD minus BC. So that is A times D here minus B times C. In other words, it is the product of the leading diagonal elements minus the product of the other diagonal. All right, so in example 20, the determinant of A would be 2 times 7, the product of the leading diagonal elements, minus 4 times 5, and that is going to be 14 minus 20, which is equal to minus 6. Example 21, we're to find the determinant of A. So the determinant of A would be 3 times 4, 12, minus 2 times minus 5 is minus 10. So this is 12 minus minus 10 is plus 10. So the determinant here is 22. Example 22 says, given that the determinant of the matrix A to 3A is equal to 3, we're to find the values of A. So the determinant of this matrix here, A to 3A, the determinant, which is equal to A times A squared, minus 2 times 3, 6, is equal to 3. So therefore, A squared would be equal to 3 plus 6, which is 9. The opposite of square is square root. A would be the square root of 9. So therefore, A would be positive or negative 3. All right, determinant of a 3 by 3 matrix. So if A is the matrix A, B, C, D, C, D, E, F, G, H, I, the determinant of A would be A multiplied by the determinant of E, E, F, H, I. So let's show you how we get E, F, H, I. We're going to cover the all the elements in the rows and the column where A is. And so we'd find the determinant of the remaining elements. The remaining elements are E, F, H, and I. So it's A, the determinant, A times the determinant of E, F, H, and I. And then B minus B, so that minus there is part of the formula. The determinant of the remaining elements after you disqualify or remove the elements which are in the same row and column as B. And so it's minus B times the determinant of B, G, F, and I plus C times the determinant of D, G, E, and H. All right, so that's the formula for the determinant of a 3x3 matrix. Now this says find the determinant of matrix A, which is 1, minus 2, 3, 0, 1, 4, 2, 1, 2. So the determinant of A would be 1, and then times the determinant of 1, 4, 1, 2, then minus 2 times the determinant of 0, 2, 4, 2, plus 3 times the determinant of 0, 2, 1, 1. This is 1 into 2 minus 4 plus 2 into 0 minus 8 plus 3 into 0 minus 2. This is minus 2 minus 16 minus 6, and the determinant here is minus 24. All right. Example 24, we're to define the determinant of A. Here, the determinant of A would be equal to 3 times the determinant of 1, 2, 0, 7, and then minus 1 times the determinant of 4, 2, 0, 7, plus 1, the determinant of 4, 2, 1, 2. This is 3 into 7 minus 0 minus 1 into 28 minus 0 plus 1 into 8 minus 2. So this is 21 here minus 28 plus 6. So it appears that the determinant here is minus 1. 25. Find the determinant of B. So the determinant of B would be 1 times the determinant of 1, 1, minus 1, minus 4, minus 1, determinant of 2, 3, minus 1, minus 4, plus 2, the determinant of 2, 3, 1, 1. This is 1 minus 4 minus 1 plus 1 into minus 8 minus 3 plus 2 into 2 minus 3. So this is 1 into minus 4 plus 1 plus 1 into minus 8 plus 3 plus 2 times minus 1. This would be equal to 1 times minus 3, which is minus 3. 1 times minus 5, which is minus 5. 2 times minus 1, which is minus 2. And it looks as if here the determinant of b is minus 10. The determinant of b is minus 10. All right, so let's have a look at this says properties of determinant. And the first one says if every element of a row or column of a matrix A is 0, then the determinant of that matrix is also equal to 0. So here you want to pay attention to these properties because sometimes these properties in the future might make some of the calculations simpler. If A is a square matrix, then the determinant of A transpose is equal to determinant of A. It says if two rows or column of matrix A are identical, the determinant of matrix A would be equal to 0. So that's also important. If two rows or column of a matrix are identical, the determinant of that matrix is going to be equal to 0. If two rows or column of a matrix are interchanged, the sign of the value of the determinant is changed. Also very important. Here, if k is a real number, the determinant of k times the matrix A is equal to k raised to the power n times the determinant of matrix A, where A is an n by n matrix. Again, not so intuitive, but it's something that can be shown to be true easily. The sixth and last says for any two matrices A and B, which are conformable to matrix multiplication, the determinant of the matrix product AB is equal to the product of the determinant of A and the determinant of B. All right, so of course, all that we have done up to this point will allow us to do questions from exercise 16A. So your homework is exercise 16A. All right, from the textbook, try these 16.6. This says let A be the matrix A, B, C, D, E, F, G, H, I, where to show that the determinant of A transpose is equal to the determinant of A. So let's start out by finding the determinant of A. Now, the determinant of A would be equal to A, the determinant of E, F, H, I, minus B, the determinant of D, G, F, I, plus C, the determinant of D, G, E, H. This is A into EI minus FH minus B, the determinant of DI minus FG plus C, the determinant of DH, E minus EG, distributive law, AEI minus AFH minus BDI plus BFG FG plus CDH minus CEG. All right, so that will be the determinant of A. Let's go for A transpose. A transpose. Let's interchange the rows and columns. So we'd get A, B, C, first column, B, E, F, second column, G, H, I, third column. Let's go for the determinant of A transpose. So A transpose, the determinant would be A determinant of E, F, H, I minus B, the determinant of B, C, H, I plus G, the determinant of B, C, E, F. All right, so this would be A into EI minus FH minus B into BI minus CH plus G into BF minus CE. Distributive law, AEI minus AFH minus BDI plus CDH plus BFG minus CEG. All right, so then we can compare. And if we compare, we can cross out the things which are the same. That's the same here. Uh-huh. Uh-huh. Mm-hmm. So with close enough examination, you'll see that the two things are identical. All right, so therefore we can conclude that the determinant of A transpose is equal to the determinant of A. All right. Here, we're asked to show that if A is the matrix A, B, C, D, E, F, D, E, F, in other words, two of the rows are identical, and the theory says that the determinant of this should come out to be equal to 0. Let us see that if it's true. So here, the determinant of A. All right, so this is off a little. Let's fix it. This should say if A is this matrix, then the determinant of A should be equal to 0. So let's find the determinant of A. It would be A times the determinant of E, F, E, F minus B times the determinant of D, D, F, F plus C times the determinant of D, E, D, E. All right. So this is A, EF minus EF minus B, DF minus DF plus C, DE minus DE. All right, so very easy to see that this is A times 0, 0 minus B times 0, 0 plus C times 0, which is 0 the determinant here is equal to 0. So here are two things we end up showing to be true, that the determinant of A transpose is equal to the determinant of A, and that if two of the rows of a matrix are identical, then the determinant of that matrix is going to be equal to 0.